In this tutorial, I'm going to work through a short notebook that I've made on how we use the logs from our ERDDAP server and some Python functions to analyze the visitors that we get to the server, primarily which data sets people are accessing and where the requests are coming from. A tutorial like this has been requested several times during the Goose ERDDAP seminar series, so I thought I would put something together. This is just one way of analyzing logs. It's quite a simple method, but I hope it might at least be a starting point for people to do some basic analysis on the visitors that they get to their ERDDAP. So I'm going to share my screen now. And these scripts, as usual, are available through GitHub. I've posted the link to the repo up the top here. There's also a short blog post that I've written that goes a bit more into the rationale of parsing logs, and I'm going to work through the script. So we have some inputs, including the Apache logs package, and some tools for analyzing data. We're using pandas and polars for its superior performance, and some plotting functions. So you'll need to add paths to your logs here. Here I'm showing how to analyze both Apache logs and Nginx logs. And now to note, these are the logs of the underlying web server. So ERDDAP has its own set of logs to run internally. Because we use ERDDAP in Docker, we find it easier to analyze the logs of the host machine itself. So these will just show the request coming in directly from the end user. Let's start with the Apache logs. So I give the path to my directory of Apache log files, and I'm looking for logs called access. There's a little parser function here, which will extract the date stamp, the referrer, so like IP address, and the user agent. So if someone's using Chrome or Firefox or whatever, and then we're just keeping the request time and the origin IP and the URL they're requesting. So here we see that's about 700,000 requests that we've got through Apache. We moved from Apache to Nginx a few months ago. So I'm also going to add the Nginx log files here. I actually got this from someone's GitHub gist, which I've posted up the top here. So it's a slightly different format, a bit more complex for the Nginx files. And here we see we also get a table. This time we've got about 300,000 requests. Again, I'm just keeping the IP address, the date time, and the URL requested. If you also wanted to keep the user agent, like if you're interested what browser people are using or what device, you can also keep that information to analyze. I'm just focusing on the core things here. Now I'm going to combine the two data frames. As people who have programmed in Python a bit will know, date stamps can be kind of a pain. So we're having to cast our date stamps into ints here and then combine them because one log is in microseconds and one is in milliseconds, I think. That's going to be a long time to figure out. So we concatenate those data sets, and now we've got one big data frame of just over 1 million rows. So a nice chunk of data for us to analyze. Now, we have IP addresses, and from those, we want to find out where our users are from. There are several free and paid services that you can use for this. Here we're using ip-api.com. This is a rate-limited API, so we prioritize the IP addresses that have visited us the most times. So what I do is, after I've requested information on an IP, I save it to a file. So the next time I run this script, it won't re-request information on the same IP address. So if I run that now, it goes through and it finds new visitors. As you can see, it's prioritizing the ones that have visited us the most. So we've got IP addresses from Germany, Sweden, Singapore, the USA, and it will add all of those into a data frame. You see at the bottom, we've exceeded the number of API responses. I think it allows you 60 hits, and then it will block you for a few minutes. So you can always wait and try again. So now we're going to do a data frame merge. So on the left-hand side, we have our data frame of requests to our ERDDAP server. On the right-hand side, we have this detailed data frame of IP addresses, and we're going to merge those on the IP address. So I run that merge. And so here we have this more detailed stuff. So we have the IP address, when they visited, what URL they wanted, and now tells us the country they were from, country code, region, city, zip code, and the LON and LAT. Mostly we're using the LON and LAT here. Another thing I do is I'm just converting quite liberally here between pandas and polars. I'm trying to use polars more as it's a much more efficient, much faster library, but there are still some things that are easier to do in pandas. But we pass back into polars for this more intensive filtering. Now, what I'm doing in this cell is I'm dropping bad requests. So on any service that you have connected to the internet, you will get various spam requests. You'll get crawlers, you'll get people trying to kind of abuse the service. So we're trying to filter this down into sort of real customers only. So the filters that I do here is if I see the org comes from Google or SEMrush or contains a word like crawlers in it, I'll filter that out. I'll then filter out what I consider to be spam or kind of automated attacks. Like no legitimate visitor to an ERDDAP server is trying to get to a .php file or your AWS information. You can block those IP addresses. Maybe I'll cover that later on another tutorial. And you drop them from this for the analysis. And then finally, probably the most simple filter you can do is I just filter for only URLs that have ERDDAP in. If they're not here to visit the ERDDAP page, then it's probably not traffic that we're interested in. And I print out here how much of the traffic remains after these filtering steps. So we see we've dropped about a third of those rows as considered sort of not genuine. And then what I'm doing here is I'm looking for the types of data that people request. So the nice thing about those, all those requests to ERDDAP are formatted with the data format that the client wants. So whether that's .html, CSV, NCCF, JSON, whatever. And I'm splitting on that dot so I can find what kinds of files people want. And then I'm also looking at what pages they're visiting most frequently. So if I make that up into a little graph, I see that the most popular page is the index page. Unsurprisingly, that's where people are landing. And you'll also see here what the most popular data sets are that people are accessing. And here we're doing the same thing, but with data types. So we see mostly it's .html, so those are web pages themselves. We get a lot of requests for JSON, KVP, graph, which is, when people are sitting there, whenever they hit the refresh button to refresh the graph, that makes a fresh request. So if people are looking a lot at the graphs on your site, you'll see that. We get a lot of requests for NCCF, as that's the netcdf formatted metadata. A lot of the scripts that I write hit those files. And yeah, down here we get the more your standard data formats like CSV, netcdf, things of this nature. Now, one of the interesting things I like to do is to filter by country, as this is typically one of the first things that people ask us is where are people visiting our ERDDAP from? We get a lot of French users on our ERDDAP, it seems, quite a lot across the pond as well, Canada and the US. I think a lot of those ones in the US are also automated bots and crawlers that I'm just not catching. Our filtering isn't particularly sophisticated. Unsurprisingly, Sweden is right up there as a Swedish organization. We have colleagues in Finland and Italy who are clearly making use of our data too. And then what I like to do is just make a nice big map. So one of these things I've done is this IP group. This is, again, quite a clumsy thing. Basically, I'm taking the first three parts or the first two sections of an IP address and combining those. So that when we're putting these into a map, we want people who are coming from approximately the same geographic location that are from the same IP block to be counted together. So that if two different users are in the same building, they might have different IP addresses, but they might be in the same IP group. So if we combine those groups and then we just do a cartopy plot, kind of centered over the North Atlantic, And here we're doing sort of a logarithmic scale of how many users are hitting our server and where they're coming from. So this gives a nice quick sort of geographic overview as to where most of the hits coming to your server are from. So yeah, I hope that was useful. As said, these scripts are available on GitHub. You should just be a case of creating the environment and giving it a path to your log files. Be aware that the first couple of times you run this, it will only have a few IP addresses to get this kind of deeper info on. The more times you run it, it will build up this ip.csv file until you've built up lots of data on all of the people visiting your ERDDAP. So from all the times I've run this, I've now got information on over 1,000 IP addresses. So yeah, you could probably set something up to make more use of that ipapi.com to really pull that data in. So yeah, thank you for watching, and I hope that was useful. If you have a more sophisticated way of parsing ERDDAP logs, please let me know, and we'll publish that here too.